There's a lot of writing here, and there's a cute little picture. A rectangle below has this area. Interesting, it's broken up. There's 70 y to the 8s, and there's 30 y to the 6s. And they broke it up like this. How cute. Okay, that's the area. The width of the rectangle is equal to the greatest common monomial factor of these two. Okay, that's the width. That's this guy right here. What is the length and width of the rectangle? So what is our width? We got to find out what we can take out of both of these. It's kind of like the last problem, huh? They just kind of repackaged it. Okay, so what I'm going to do is I'm going to write it like this. I'm going to write it like a binomial. Okay, I'm going to write these two guys, and I'm going to say to myself, what can I divide both of those by? And you guys are going to say, what? What can I divide 70 and 30 by? 10. Yeah, 10. Now, if that's not the right answer, don't worry. There's a checkpoint when we finish. And how many y's can I take out of both of these terms? I have two terms. Yeah, I can take y to the 6 out of this one and this one. And so I put y to the 6, and this is how I write it when I'm done. I do 10, y to the 6, and then I put my binomial. I put in here what I get when I divide both of these by this term. So what is 70 divided by 10? 7. And what is y to the 8 divided by y to the 6? 3. Y to the 3, right? We have to go, no, not 3, silly. We have to go 8 minus 6. And what is 8 minus 6? Dose. Y to the 2nd. Okay, then we go plus because it says plus right here. And then we have to go 30 divided by 10, which is 3. And then look, y to the 6 divided by y to the 6. What is y to the 6 divided by y to the 6? 1. Oh, no. That's why you don't have to write him. And that's your answer. So our width. So because, you could just, subtract the 6s. You can think about it like this. You get y to the 0. And what is anything raised to the 0 power? 1. Oh, no. Okay. Now, what if you didn't pull out the greatest common factor? What if the 10 was not the greatest common factor? The way you would know that is by looking at these two numbers right here, the 7 and the 3, and you would ask yourself, is there something I could divide both of these again by? Okay, and now here we clearly cannot. We can't divide 7 and 3 by something else. But I just want to let you guys know, if there was a number that we could take out of both of those, what you would do is you would multiply the 10y to the 6 times that number. Okay, and then inside this binomial, you would write your new binomial after you divide out that number. And that's the checkpoint that I was mentioning earlier. Okay, so let's write out our answers. We have 10y to the 6, and then we have 7y squared plus 3. Or you can write 3 plus 7y squared, except that's not quite standard form. Usually you would write the y squared first.